Hi, welcome to video 6 of the differentiation topic. I am asked today we're going to look at equation of tangents. So the first thing we're going to look at is the success criteria. Today we're wanting to be able to find the equation of a tangent to a curve, and there's 4 steps to this one. Being able to calculate the y-coordinate using an initial equation, being able to differentiate to obtain a formula for the gradient, being able to substitute the given x-coordinate to calculate the gradient at a given point, and then being able to formulate the equation of a tangent using y minus b is equal to mx minus a. Okay, so everything here can be used as a note. First one, the equation of a tangent. A tangent is obviously a straight line that touches a curve at one point. So just like any straight line, we can find the equation of a tangent if we know a pair of coordinates on the line at any point. Most of the time, if not all the time, will be where it meets the curve, and then the gradient as well. So if we know the coordinates and the gradient, just like anything, we can use a y minus b is equal to mx minus a. Okay, there's an example there. Find the equation of the tangent to the curve y equals 3x cubed minus 4x squared plus 9 at x equals 2. I would pause the video just now, have a wee try at that, and then I'll move on and show you how it's done. Okay, so looking at this example, we have 2 things we need. We need a point, like a set of coordinates, an x and a y value, and we need the gradient. Okay, if we know the x value, there's a formula there waiting on us to get the y value. Okay, if x is equal to 2, that means y is equal to 3 lots of 2 cubed minus 4 lots of 2 squared plus 9. Okay, so 2 cubed is 8, 3 times 3 is 24, 2 squared is 4 times 4 is 16, add 9. So 24 take away 16 is 8, add 9 is 17. So the coordinates we have are going to be 2, 17. Okay, that's the coordinates that we can use in our equation. Now, to find the gradient, and this is really the big part of this, to find the gradient, we need the differential. Okay, the gradient is always equal to a differential. So the gradient is equal to dy by dx, which in this case, differentiating that is 9x squared minus 8x. Okay, so that's a formula for the gradient. We want to know it when x is equal to negative 2. So when x is equal to negative 2, dy by dx is equal to 9 lots of 2 squared minus 8 2's. So 2 squared is 4 times 9 is 36, take away 16 is 20. Okay, so my gradient is 20, and my point is 217. Okay, and then I'm just going back to what I know from straight line topic. Y take away 17 is equal to 20, x take away 2. Okay, and then multiplying out the brackets means y is equal to 20x minus 40 from the 20 times minus 2, and then add 17 is minus 23. So the equation of tangent, the 4 steps: finding the coordinates if you don't already have them, getting the formula for the gradient, getting the actual specific gradient where you're talking about, and then using your y minus b to get your equation. Okay, so 4 steps to get this. Okay, the second example we're going to look at is just a little bit come another direction. Okay, so this curve here has equation y equals a third x cubed plus half x squared plus 3x minus 7. Okay, and this time we're looking to find the coordinates where the tangent is 5. Okay, so for this one, I'm not looking for the equation of a tangent. Okay, I'm looking for where the gradient is equal to 5. Okay, now I know the gradient is equal to the differential. Again, you might want to stop it and try this yourself here. So if I get the differential, dy by dx, 3 times a third is just 1, so that's just going to be x squared. 2 times a half is just 1, so that's just going to be a single x. And then 3x differentiated is 3. Okay, now I want to know where the gradient is equal to 5. That means I want to know when the differential is equal to 5. So I want to solve that equation. X squared plus x plus 3 is equal to 5. And because there's more than one power of x there, it needs to be equal to 0 and it needs to be factorized. So it's going to be x squared plus x minus 2 is equal to 0, which factorizes to x plus 2 and x minus 1, which means your solutions to this is x equals negative 2 and x equals 1. Okay, so that's just a bonus problem solving question there, a wee example for you to see. Okay, so going back to the learning intention success criteria, to find the equation of a tangent, I know we only did one example here. You should obviously be looking to go and do a lot more. To find the equation of the tangent, we want to be able to calculate the y coordinate using the initial equation, differentiate to obtain a formula for the gradient, substitute your point in to get your specific gradient for your situation, and then use y minus b equals mx minus a to get that formula or to get that equation of the line. Okay, thanks for listening.